All right. In looking at the kind of reviewing the stuff that we talked about in 2.1, we looked at the way that relations are set up. We found some were set up as ordered pair. Another way that you might see relations set up is kind of this visual method of input and output. And what will likely happen here is if you see kind of a list of numbers and then they are visually connected to outputs. So you might see inputs and outputs or relations modeled in this way. And basically what it's saying is just another way of kind of interpreting the information. If you look here and you want to identify the ordered pair that correspond with this visual imagery, what you could do is you could look to see, if I took an input of -3, what's the corresponding output? 7. If I took an input of 0, what's the corresponding output? -7. What if I took an input of 2? The corresponding output is also -7. And finally, my input of 5 has a corresponding output of 2. So if you looked at this set, is this going to model a function or not be a function? Remember, in a function, for something to be a function, inputs have to be consistent, have to yield consistent outputs. So none of the same inputs can yield different outputs. Now, can different inputs yield the same output in a function? Yes, it's just not the other way around. You can't have different inputs, or I'm sorry, you can't have the same input yielding a different output. So is this going to model a function? Yeah. Because every input has a specific output. In fact, there's no repeated input, so it's not even a problem. You don't even really have to test too much. Okay, so let's take a look at another case of this. And let's say your inputs are just a little bit different. And let's say the inputs look like the following. Right now, if you are evaluating this kind of visual image and trying to identify whether this is or is not a function, if we find the ordered pair that corresponds, so an input of -3 is going to yield an output of what? 7 or -7. So right away, can you tell whether that is or isn't a function? Yeah, this is no longer a function, right? Because the same input is yielding inconsistent or different outputs. So right away we know this is not a function. Okay, and then the last input, if we were looking, 5 yields a 2. Okay, but that doesn't really matter because once you see that the same input yields different outputs, then it's not considered a function. So in addition to this ordered pair way to model whether something is or is not a function, and this other kind of visual way, we also talked about the vertical line test. Okay, so when you're looking at a vertical line test, what you're looking to see is there a vertical line that passes through your graph in more than one place? So would this green graph pass the vertical line test? Is there any place where a vertical line would pass through this graph in more than one place? No. Therefore, it passes the vertical line test, which means it is a function. Okay, so if it passes, it equals a function. And what about a circle? Does a circle pass the vertical line test? Can we find somewhere on here a vertical line that passes through our graph in more than one place? Yeah. So if this case, if it fails the vertical line test, it's not a function. So a circle is not considered a function.